Do you think you can go over number 19 in log 2? I think that's how it's pronounced.
Number 19 of log 2. Okay. Let me grab my notes. I have a hard copy of the notes, so this is log 19. Log just log 1 or log 2?
Just log 2.
Number 19, right?
Yes.
Okay. Homework. Okay. This is log 2, number 19. And number 19 goes like this. Okay. Log base 2 of 1 over root 2. Okay. We want to know what's the answer. Yeah?
Yeah.
What's the answer? Okay. There are a couple of different ways to do it. So I'm going to show you the first way to do it. You can just go straight forward. Okay. What you can do is you can work on converting this guy into converting 1 over 2 into something like this. Okay. You want to convert this whole thing. Oops, sorry. To log base 2, if you can. Sometimes you can. Okay. The fact is you always can. You always can. You just have to be patient with yourself. Okay. You want to get it to 2 to the power of something. Okay. This is one way to do it. I'm going to show you a couple ways to do it. So this first way to do it is that you just work it, say, oh, okay, so this is 1 over root 2, right? And square root of 2 is 2 to the power of half, yes? Mm-hmm. Okay. And then what? We have a definition, really. Negative n is equals to 1 over e to the power of n. Okay, so let me make the fonts larger. Okay. So now you should get log 2, log base 2, 2 to the power of negative half. Are we there? We're there, yeah? Are we there?
Uh-huh.
What will be the answer? What will be the answer? So we got there, right? We we go through a couple of steps, just change the way of writing this omega, this baloney, into the power of 2 to the power of something, right? That power is going to be your answer. Okay, so I'm going to take this and show you, bring it to the place that we had seen yesterday. Yesterday, what did we do? Two to the log base 2 1/8 is written as log base 2 2 to the power of what? -3, right? 2 to the power of -2. And the answer is just -3, -2, and so on and so forth, right? And this is 2 to the power of 2. Do you guys see that? Yes, this is 2 to the power. Do you guys see that there's the same idea? And using power property. And this one is 2 to the power of 3. Okay, and what did we do here? It's just this number is a little bit different. You got it? But how do I know this is the answer? Definition. Okay. In the whole time, you need to keep in mind the definition. Okay, so I'm going to bring back the definition that we typed yesterday, right here. The absolute, rock solid foundation for handling logarithm is the definition. Is a definition, right? And of course, yesterday I gave you this general form, and then we went about to do this example, it's base 2. And they're all similar. They're all similar. Now, for example, from here, right? We did the base 2 case. Okay, we did the base 2 case. Do you guys follow me? All right. You want to find a number. You want to find this number. Okay, this will actually relate to another method. Okay, so let me talk about the other method. But first, I need to tell you, how do I know this is the answer, right? How do I know this answer? Of course, this is the answer, because this number power 2 is exactly 2 to the power negative half. And that's what the definition says. You follow me?
Mm-hmm.
You got that, right? Because I'm going to put this over here. Okay, this is the quoting a property. So now when if it's log base 2 to the power 3, it is equals to 3, right? Because 2 to the power 3 is 2 to the power 3, yeah? You get that? Because this number power 2 is 2 to the power 3, therefore log base 2 of 2 to the power 3 is going to be 3. That's the definition. So now 2 to the log base 2 to the power negative half, this number turning into negative half. So the answer is going to be negative half, because this negative half power, this base 2, is going to be exactly that. 2 to the power negative half is the same as 2 to the power negative half. Oh, sorry. Is that right? Do you guys follow me? Do you guys see that? Okay, let me see the chat. I can't find the homework page. What page is that? Actually, I will be asking for your because I have the older version of the printout. So if I tell you the page, it should be after page number 44. Okay, in the logarithm session. Go through the notes, okay? You might see that I don't always give you the page number anymore. I want you to go through the notes, looking for what you need. The title is correct. Okay, the title is correct. Go through the notes over and over again. It will help you. Okay, because I will be assigning you homeworks all over the notes. You have to go through the notes over and over again. You know what you need to know. Okay, 76. Thank you. Okay, I want you to go through the notes. You guys see that? Yes. This is the absolute foundation of all things logarithm for base B, for any base. This is base 2, okay? This is base 2. What we're doing here, we're really just building the solid foundation. You will see, and I will show you that how everything else comes after rely on this piece of knowledge, this piece of knowledge. If this piece of knowledge is missing, or you say you didn't plot the graph, okay? You didn't plot the graph, right? Oh, this is just too easy for you. I understand it because it is very easy. Do you agree? When we plot the graph, do we agree that it's pretty easy? Very easy. It's very easy to do, and it's very easy not to do. And the consequence of not to do it is very, very serious. It's very, very serious. Okay, so next, I promise you, I will show you another method, right? The other method, this method I would say I show you probably is not very common amongst you. Okay, it's not just statistically speaking from my personal experience, this is not something very commonly seen with you. Okay, maybe that's the reason I should put it first, right? The other method, which is more commonly done, where because I saw this from my student in the past, okay? The other method actually is go direct to definition. Okay, so you just compare log base 2, log base 2, omega. So omega is 1 over that, right? 1 over square root of 2. And we want to know what the answer to that. Some people use question mark. Some people use X. It doesn't matter what symbol you use. So I decide I'm going to use a symbol that's rarely used before, just to make a distinction. Okay. It doesn't matter. Well, because if this is a question mark, this is going to be the question mark. Do you follow me? If this is if this is X and this is X, you follow me? So it doesn't really matter to me. Does it matter to you now? It should not. It should not. Okay. So I'm going to use this triangle symbol. I just stick with, to my initial notation. Since we know this is the omega, so this is omega. So we first need to put the numbers in place properly. So you can see in this entire definition, what we need to know is the triangle. So triangle is going to be the answer to the given expression. So the triangle is also going to be the power, that power 2, I give us 1 over root 2, right? So then you just need to then you basically go through these steps to figure this out. Do you follow me? You basically go through these steps to figure out, because then you say, oh, 2 to the power what, right? In this case, you actually solve an equation. Okay, your narrative. So, okay, I'm going to write it down. Think out aloud. And here's the narrative. You created a narrative for yourself. Okay, it said, okay, if I talk about there are only 2 kinds of statements in mathematics, and this is the if statement. Okay, whether you were being aware or not, that's what you were doing. You created a narrative, and this narrative you basically say, okay, 1 over square root of 2. 1 over 2 square root of 2, and 2 is, or you can do it the other way. You can say, okay, square root of 2, right? Raised to the power of a -1. Raised to the power of a -1, right? I'm using this guy, right? I'm using this guy. And then inside the parentheses, square root of 2 is 2 to the power of half. And therefore, in the end, you get 2 to the power of -half. You follow me? So you have 2 to the power triangle. So in the end, right? If you shorten these two, this expression, right? Take out the intermediaries, take away the intermediaries, that's what you get. And obviously the triangle is equals to -1/2. Do you guys follow me? And the other major reason this is true is because of what? Because 2 to the power x is an increasing function. It's a 1-to-1 function. Okay, you can only do this if it's a 1-to-1 function. If it's not a 1-to-1 function, for example, we're going to talk about this is only true. Very few people, I would say very few professors may talk about this. But I don't have the statistics. I didn't go to their classrooms. But from my students' response, few people talk about this, okay? Only for 1-to-1 function, you can do this. Only for 1-to-1 function, you can do this. Do you guys follow me? Okay, so let me explain to you the meaning. The meaning of 2 to the power of a this triangle, right? And versus this guy, 2 to the power of half, the -1/2. Fundamentally, in this case, the triangle is the input. And 2 to the power triangle is the rule. It produces an output. And now, for this expression, it's basically, you know, the input is a -1/2. Okay, this little minor step actually is very, very critical for us to understand some of these concepts, which sometimes when we were in a hurry, we may not address. Okay, and then of course, we want the output to be that. I want you guys to see things from the perspective of function, remember? Because with that perspective, everything would be crystal clear for you. That one sentence we started at the beginning of semester, okay? So what is this saying, okay? So what does this say? This basically says if the output are the same, the input must be the same. You follow me? So the next statement I can say then, okay, then the input will be the same. You follow me? Do you guys follow me? This narrative we created, okay? This piece is something I see a lot of students do, maybe different ways, okay? Maybe it's, you know, with more lines. What essentially is said, there are only two kinds of statement in mathematics, right? If this is true, which means the output are the same, and then the input must be the same. Someone wants to say something, go ahead. Who is trying to say something? Right?
I guess the students confirming when you ask, do you agree? They were confirming your
You're confirming my my
steps.
message.
Yes.
Okay. Okay. So, but I didn't mean to cut you short because I didn't hear you clearly. Okay. But if you have any questions, so I want you to see everything from the function's perspective, because in the end, let me assure you, in the end, everything looks easy to you. Everything is clear to you. Everything is simple to you. So you no longer have to be so struggle with all these different techniques, just only two kinds of statements. Okay, now, you see from the function's perspective, this too means that you have the same output. When you have the same output, then you surely have the same input because this function is one-to-one. Only for one-to-one function, you can have such assurance. This is not true for any function. Okay, for example, if I know sine x is equal to sine of y, right? Can you say x equals to y? Can you make such a statement?
Yes.
Okay, we got a yes. How many of you think yes?
Professor, for example, sine 30 degrees 1/2, but sine of 390 degrees also is 1/2. Or sine of 120 degrees is 1/2 too.
I assume that
not-
everyone in the classroom actually know what I'm talking about, right? What is sine x? What does it mean sine x equals sine y? It's an if statement, right? It basically says, okay, x, right? We apply the rule of sine. But very soon we're going to get into the sections of trigger review. Okay, and the output is what? It's sine x. And then it's y. Okay, I'm going to go with a quickie way. Okay, and the output becomes y. And this says if the output is same, can you say the input are same? Farouz just give you an example. No, this statement is completely wrong. Because sine is not one-to-one. And you have numerous examples of similar nature. For example, x squared, right? X to the power 4. You don't even have to get into trigonometry to realize this is not always true. Okay, so if you started with this statement, you're gonna get 0. No matter what you do, whatever skill you have. This is why it's so important to understand these concepts I've been addressing from the beginning. Function, one-to-one function, increasing function, decreasing function, truth table. Essential for your success. Essential for your success.
So Professor, one-to-one is the keyword here to watch
That's
for.
right. Only for one-to-one you can do this. Okay, 100% of students I've taught in the past, they came to my class, they have no idea about these concepts. If you don't have these idea about these concepts, of course you're not going to do well in calculus class. It's absolutely guaranteed. Okay.
Thank you.
All right. So what is the example I can give you? Farouz give you an example, right? There are many examples. Why? Because this statement is false. And I need to give you a counterexample, right?
If one false, then false.
Yeah, there are many such examples. For example, 0, right? Pi, easy examples. Sine of 0 is 0. Sine of pi is 0. The output are the same. Can you say 0 equals to pi?
0 radian equals pi radian? No.
Yeah. Can you say 0 radian equals pi radian? Obviously not, right? You can see this is the reason why I introduced that one-to-one function at the beginning, because I need it. I need that to be demonstrated and used. All right. So this is the second method. Okay, but the second method, we actually will address it in the future as well. One more time. Does everybody follow me? The second method.
Mhm.
Any questions? Mathematics has to be very rigorously taught and rigorously learned. Otherwise, it's like a building. It's going to crumble and you're going to lose points left and right. But if you have the initial foundation set up correctly, strongly, and you think in these terms, I'm basically showing you, you think in these terms, okay? You think in the terms of input, output. You think in the terms of output, input, and their relationship all the time. Besides, you only have one input, one output to think about right now. You don't have much more, nothing more. Nothing more. I promise you, okay? All right, so these are the two different methods which, inspire me to address these fundamental issues. Why these fundamental issues are important, right? Remember quiz number 1 at the beginning of semester? Number 9 on quiz 1. Number 9 on quiz 1. Okay, let me type that question for you. Okay, remember that quiz 1 on page number 3? Quiz 1, page number 3. I was telling you, this is the question. This is the set of questions the calculus author put together. Okay, I was barely a copycat. This calculus author put together. Question number 9 says, if f of s is equals to f of t, okay, then s is equals to t. Right? Then s equals to t. Is this true or false? What does it say? It's essentially saying the same thing, but mine is an example, right? Of course, this one is addressing arbitrary f, right? Arbitrary f, any function. You have to think in the terms of any function. We know there are infinite many of them, right? This is f of s, and this is f of t. Do you guys see that? Do you guys see that?
Mhm.
This basically says if the output are the same, can we declare the input are the same? And this statement says this is true. Is this true? Because when someone says something like this, that person believes that's true. Is that true?
Is that safe to say if the function is 1-to-1, then it is true or no?
Well, we don't have that condition. That condition was not given.
Right.
We don't know if f is 1-to-1 or not. The answer is false.
That's right. So if it is not a
The answer is
condition,
false because we already have a counterexample here, right?
yes.
Do you guys understand? Remember, I at the beginning of semester mathematics statement, if true, always true, false, once false. This is that one of those false ones. Right? So does those criteria sounds more concrete for you now? That's what I'm hoping for. Right? A true statement is true always. If a statement is false once, false. There's no discussion throughout in the trash can. All right? But don't worry. If you have any questions, please don't hesitate to ask me, because I believe that what I do is the way I teach pre-calculus is it's not everybody, not everybody do it this way. And I wasn't even taught this way. Okay. But after years of experience, I believe that this will be the way that will help you the best. Okay. And you will come back to tell me, I hope. Okay, give me some feedback. Anyway, so these are the issues, right? You can see we have all of these fundamental principles in our mind, and we see they're being applied. So this is the homework question answered. Do we have another homework question to be answered? I'll be very happy to. I'll be very happy to.
I
Any-
actually do, sorry.
No worries. No, go ahead.
So for log of 1, can you do number 27?
Number 20, log
got-
127.
Yeah, because I got the answer, but I don't know if it's correct.
Okay, log 120. 27. Do we have 27? Oh, log 127. Sorry, log 127. Log 127. Right? Log 127, this is about converting logarithm to exponential and vice versa, right? So you have a bunch of exponential and you have a bunch of logarithm, okay? So let me just simulate, right, that form. So number 27, you have a column of exponential and you have a column of logarithm. And we're converting to each other. Logarithm. Number 27, you are given a logarithm. ln of x plus 1. Well, we haven't really talked about ln. We're going to talk about today. But since you asked this question, I'm going to just address this question right now. So we want to write down the exponential form. The absolute foundation to address this issue is a definition. Okay, so I'm going to take this one with us. This is a definition that's related to it. And of course, this time, I'm going to go back, put it back to the original, the general form, where b is greater than 0, not equals to 1. And what is ln? Anybody know what's ln? 10?
I'm gonna say, oh, no.
Very close, Wilbur. So can an example for this be squared function? Oh, certainly. Yeah, certainly, absolutely, Wilbur, you're right. Okay, I'm sorry, I missed that message, okay? I believe you were talking about the, you know, the one-to-one function, right? Related to number 9, absolutely. Okay. Now, number 10. And he's talking about the base is 10. No, the base is not 10. The base is E. Okay. Base 10. Whoopsie. For base 10, which is 10, right? And this will be log. Will be log. Okay. For base E, if the base is E, this is going to be E. And that whole thing would be called ln. This is called a natural log. Okay. Basically, ln is the shorthand notation, the shorthand word for log of natural. Log of natural, or natural log. Do you guys follow me? N for natural, L for log. Do you follow me? ln. Log, natural log is the singular log function you are going to use all the time in calculus 1 through calculus 3 and beyond and beyond. Okay, so of course we're going to address this. Now, so now you have ln of x plus 1. So this is x plus 1, right? So omega, so this guy x plus 1, right? So this guy is x plus 1, and this guy is x plus 1, right? And the triangle is 2. So what should be that exponential form? And this is the exponential form. That's the answer. Do you follow me? So basically you apply definition. On the one side is log form, and the other side is exponential form. Any other questions on homework?
Wait, so you would basically just do, you would do E to L, no, you do
Base
L and
E,
E.
base E powered by 2 is x plus 1.
No, I'm saying like to get it, you would basically do E to ln and then put it on both sides, and the ln and the E would cancel out, just leaving us x plus 1 equals E squared, right?
Can you write down your work and bring it up to upload it? I heard something very interesting. I have to comment. Could you do that for me, Jake?
I don't know if I can type it, it's kind of long, but.
Don't worry. Write
So-
it down whenever you're ready.
Okay.
Okay, write it down and upload it on as a picture. I want to show to the class because I want to comment on it. Any other questions on homework while Jake is preparing his work?
Would it be okay if I can post on Pronto, because I'm currently not on phone Zoom, I'm on computer Zoom?
You want to put it on Pronto?
Yeah, because I'm not currently on my phone, my computer
Oh,
can take a picture, so I have to post on my phone and post on Pronto, would that be okay?
you mean you're gonna submit later?
No, I can't submit it right now. I just have to put it through Pronto currently.
Oh, yes, that's fine. So how soon you gonna submit? Because otherwise we're gonna move on to something else. But we can come back to yours later, because what you just mentioned is very important to be addressed. Okay. The reason I want to clarify and I want to get your questions is that once again, oh, perfect. Great. That's from Pronto, right? Thank you, Jake. My phone also received it. Wonderful. Thank you for sharing that, Jacob. Okay, I need to download it because we need to just tweak a little bit. Just we need to turn it a little bit. Okay. Hold on. Share screen. There. Okay. This is what you learned before.
Kind of more or less, I just kind of remembered about what I did.
Okay. In principle, it's okay, but unnecessary. This step is entirely necessary. I don't know why teachers teach it this way. Even though it's not wrong, it's entirely unnecessary. It's entirely unnecessary because I've seen a lot of students doing this. So I suspect some teacher teach it this way. Okay, so it's not wrong. So this is my comment. Not necessary. Not necessary. Okay, what's being done here? Okay, what is being done here is that this teacher basically take these two ln x plus 1, and he really did not use the definition directly. So this student, everybody write down this. Okay, I'm going to explain to you why. I'm gonna explain this why, because I'm going to turn to the next page. Do you follow me? So could you write it down? I'm going to explain it to you. you write it down? Do you have a narrative for what's being done?
Can you say that one more time?
Do you have a narrative for doing this? If you have a narrative, please type it on chat. Would you do that for us? But
Also-
it's you know, it's not required. If you don't, that's fine.
No, I don't understand what you mean by narrative.
The reason from one step to the next.
Oh, it just like it just for me, it just kind of helps me write down the next step, what to do. It just helps me for it.
Okay. So I'm gonna give you the narrative. Okay, I'm gonna give you the narrative. Are you guys ready? Okay. So from here, okay. Basically, this teacher, whoever have taught you this, when you do this, you have created a if statement. Okay, you said, okay, if this is true, then I'm going to take these two and e raised to the power ln x plus 1 equals to e to the power of squared. Okay, and the left hand side, this guy is equal to x plus 1 indeed. Do you guys know why it is equals to x plus 1?
Because the ln and the e cancel out, or they get rid of each other.
Okay. The ln and e canceling out. That's the narrative. That's the narrative. So what's been done here? Okay, what's been done here? Okay, explanation. Explanation. Oh, explanation, is that right? Explanation, okay. So this means that if these two are served as input, okay, what you do on the second line, you evoke another function. And the other function is e to the power x, right? It's e to the power x. So e to the power of x. So you're going to take this guy as input and give it to that. Okay, and the next one, you're going to give the 2 to e to the power x as well. Okay, that's what's been done. So what it's saying is that if these two input are the same, and after they go through these two functions, and they're still the same. Sorry about that. So, and this, the output is same. Do you guys see that? Yes?
Mm-hmm.
That's what it means. Because the same function act on it. And this same function, E applied to it is a one-to-one function. It's a one-to-one function, it's okay. So from this statement, the next statement is true. And the next statement, you say cancellation. I often hear this word is being used. I found this word used is very ambiguous. It's very ambiguous. It's not concise. In fact, it's actually not a very, I'm not going to spend too much time here because we will be addressing this one in a little while, very, very soon. But the cancellation is not the right word. Okay, do you know what I mean?
Yeah.
Cancellation is not the right word. All right, so the next step, and because this guy equals to x plus 1, and therefore it says, okay, since these two output are same, therefore that. So that's why I said it's not necessary. This step is entirely unnecessary. Unnecessary. C-E-S-S-A-R-Y. Entirely unnecessary. Just go straight here. Okay, just go straight here. But nobody can say you're wrong. Let me assure you, nobody can say you're wrong. So let's move forward. Okay. Do we have any other homework issue? Because I'm going to stop the recording and restart the school recording because this piece will I'll be documented as a homework question session. Any other homework questions?
No, that would be it. Thank you.
Okay, great. Okay, I'm so happy for these questions.